So hello and welcome friends to our channel Intro Mech, and here we discuss about basic mechanical engineering concepts. So guys, as you know that we have started our new series regarding digital engineering tools, and these tools are very helpful for designing say your mechanisms or machines and many other things. So these are the digital tools which are freely available, and Festo is manufacturer of pneumatic and electric actuators. And I'm not promoting here Festo, but it is just a tool which is freely available. Anyone can access it, and you just have to enter the correct inputs of your system, and then you get the output from the system, and you can use those outputs for the selection of the product. So this is how it works. So without wasting time, let's get started. So you have to enter the Festo online tools on the Google, and you will get this site Festo Industrial Automation. Just click on that and you will go into the site. Just go into the products and you can see the different options over there: industrial automation, process automation, and then we have digital engineering tools. Just click on that and we will enter into the digital engineering tool window. So this is the digital engineering tool, and you can see there are different options available like gripper selection, the pneumatic sizing, CAD configurator, and so many other things are available over here. So these are all the online tools which you can freely utilize, right? So what is important is you should know your system, you should know the inputs of your system, because unless and until you enter the correct inputs you cannot get the proper output. So today we will see the grippers. The grippers are widely used in the automation. They have lot of applications. So we have 3-point gripper, radial gripper, and angle gripper. So each one has some little bit different configuration. So let's first see the gripper, the 3-point gripper. Now here you could see the information about the object and data for a single gripper finger. So all this data you have to enter into the system, and that's why it should be correct. Unless and until it is correct, the system will give the wrong output. So distance, uh, line, center of gravity. So here are some information they have given, some tips and hints they have given. What is the x distance? So when you design the finger, the gripper, the part, you know the x distance. That means you know that where my x distance should be, so you have to enter that. Then weight of the object, obviously as you are designing you must know the weight of the object. Then the the required stroke. Now this stroke you can read out the tip and hints that the size of the required overall stroke, that is combined travel of both the jaws. So that is very important. It is a combined stroke. That means the left arm or the right arm is moving that distance, that is the total distance. So if you require the total distance as 4 mm, then put the 4 mm over there. So that is the combined travel of both the jaws. Then you have data for a single gripper finger. You have weight of one gripper finger now that you have to enter. So you have a calculator over here, and while designing you can have different shape of the finger, but you can just approximate that shape and you can directly put the value of that gripper weight. So we have a calculator over here. You can see the material. Let's say we have aluminum, and then we have a cube, and let's have some approximate uh, values over here. My gripper length is approximately say 60 mm. Then I have some width of 25 mm, and the height, let's say is like we can have, let's say it's like 5 mm. So okay, so that will directly give the gripper finger weight, or you can directly put that value. Then again we have a distance of zero line from the center of gravity. You can see over here. So this is the distance x, and you can, you have to enter that the clearance from the fingers center, right? And that one was for the body, and this one is for the finger. So that is the difference. Then distance of zero line from the gripping point where you are actually gripping the object. So that is the distance of gripping point. Now here we have some information regarding the motion, the acceleration, like in x direction, how you are mounting your gripper. Depending on that, you have to select that x direction, y or z direction. Then the maximum linear acceleration you have to put, like how fast you want to open and close these grippers. These values dependent on your cycle time, so you have to put that value over here. And then the acceleration direction, you can see the xyz they have given according to the mounting position, right? Then you have mounting position, the gripper position they have given. The gripper position, you can see the vertical or horizontal or upright, how you are going to mount. And then the gripping direction is closing or opening, that the direction of your gripper, like how it is like opening or closing. Then you have a gripper gripping frictional force or the positive locking. Now you can read what is this. The fingers without gripping inclination, that is purely frictional, or fingers with gripping inclination, that is with the partial positive engagement. So that is dependent on your application, which type of part you are holding, whether you want partial positive engagement or you just want to grip the uh, part with the help of friction. So let's stick to the frictional force. Then we have other specification, working pressure, that at what pressure you are going to operate the gripper, so that you have to enter. Then the coefficient of friction, that is very important, like that is materials. They have given two materials, like we have the finger material and the material which you are gripping. So these two materials will be different, having different coefficient of friction, and that is why it is very important, because it plays an important role in the gripping force calculation. So you have to enter this value, and you can use this tool to have this value. So you can just put like two materials over there, and here is the value. Then you have a safety factor, that is very important, depending on the safety required for your design. You can have the safety factor. And then the device temperature, at what temperature you are operating, that is nothing but the device temperature. And here are the your output results. You can see the standard grippers. Now the system is giving you the comparisons, like okay status. These are the results which are required results of our system, and these are the maximum possible results with these grippers. So you can see the first one, you can have the required static retention force, and the dynamic retention force, intermediate distance of the pressure point, then dynamic longitudinal force. Now if you click on that, you can actually know what it is, the dynamic lateral force, then the transverse force and lateral torque. All these parameters you can know, and here are the maximum possible uh, parameters of the selected gripper. Right now you can see the second gripper, the third gripper, and all grippers are okay. So this is the thing. And you have the standard grippers. Then again you have other option available also. So from these thing, we have then again robust grippers also. So in the robust gripper, you can see the different grippers. Now these are robust, that means these are a little bit heavy. You can see the mass of these grippers are higher than the standard grippers. So again, depending on your space constraint, your force constraint, and all those things, you have to select these grippers. If your gripper is going to get mounted on some say robot, you have to see what is the weight of the gripper. Now here you have options of 2D, 3D, and accessories, datasheet, documentation. You can go and check out the accessories and datasheet and all other things also, right? So this is about 3-point gripper. Now let's check out the angular grippers. What is the difference here? Now you again, you can have the application on the image, like what it does it look. Then again you have the information about the object, the distance from the center of gravity. Now here it is the information about the object. So this is the distance from zero line to the center of gravity you have to put, then weight of the object and the required opening angle. So this is dependent on your application you have to put. Then the data for a single gripper finger, weight of the gripper finger, the distance of zero line from the center of gravity of the finger, and the distance of zero line from the gripping point. So this is related to the gripper finger, the center of gravity of the gripper finger. So you have to understand these parameters, right? Again we have this information regarding the motion, the acceleration, then we have the maximum acceleration thing, the mounting position. Now let's take the horizontal mounting position. Now here you can see what is the y direction, right? My jaws will be opening in y direction, that's why I've taken the acceleration in y direction as 2 mm 2 meter per second square. This is the motion. Then the gripping force, the frictional. Now let's select the positive locking over here, and what is the gripping inclination, the angle that is required, so we can have the angle as it is. And then we have working pressure, coefficient of friction factor, and device temperature. Now again we have these many options which are suitable for our application. We can check out these different applications. Now each one has some different values, the total weight is different, right? uh, you can see some are heavy, some are less heavy, and you can also check the results. You can also compare the results over there on the bottom side. And then you have some micro grippers, but we can see no micro gripper is suitable for this application. Their weight is less, but they are all not okay, so we cannot have any micro gripper. Then in again standard gripper, if you could see the results, we have different options again, and you can compare the results, the required results, and the maximum possible results. Now here you can see for this application, the gripper is getting loaded only for the 7% capacity, the 7% static capacity of the gripper. And that means the gripper is not getting fully utilized, we can say, right? So instead of going for this heavy application, heavy gripper, we can have some gripper which is having little bit more loading. What does it mean is that gripper is not getting fully utilized to its potential. We are selecting a oversized gripper, we can say. So let's go to some lower series, and here we have the total weight also reduced, and we can see the results for this one. And then this one we can see now, this is like little bit more uh, heavily loaded. So according to that, we have to select this gripper, like what is the availability, what is the mass, what is the cost, what is the lead time. So basis on all these parameters you have to select the gripper, because we saw like we have n number of different options which are suitable for the application. But how to select from these options is also a very important thing, and based on all these parameters you have to select the gripper. So this is it guys for the today's session. I hope you liked the video and you got some new information, and you can utilize this tool. This is totally freely available on the internet, so you can use it easily. So thank you guys for the patient listening. Thank you. And if you have any doubts, please do write into the comment section, we can discuss over there. Thank you.